Alright guys, so welcome to today's tutorial video. In today's tutorial video, I would like to discuss on how we have done this air combat right here, alright? So this is not the best air combat on Roblox, but it is a start and it, shows you the concept of air combats in general, at least in my opinion, okay? So we have a local script right here, which obviously is able to detect controls, and then a remote event right here will be fire server. This will lead to this server script to react to it. And one problem, or yeah, maybe problem, not really a problem, but let me just explain. So, one thing which I have done wrongly, and I'm honest at this point, is that I did not really handle all of the visuals, or barely any of the visuals on the client. All right, so this air combat right here is mainly server-sided. I'm sorry for that, but that's just how it is. Okay, I'm sorry. So we have the server script then, which is going to react to this fire server, and then the air combat is mainly being handled on the server script. And as you can see, we already have this GPO shockwave right here. So what this server script does in one line is that it fire clients to all clients, and then this air combat visuals right here reacts to that fire client and then creates a shockwave underneath the target, alright, once the target is being slammed onto the ground. And that's the reason why we have this GPO shockwave module from my previous videos right here, okay? Now, let's go inside of this local script and then let's discuss everything in detail, okay? So let me zoom in. Alright, so the first thing which we have right here is a variable which refers to the user input service. As you guys know, this service is responsible to detect user inputs, such as key inputs, mouse inputs, gamepad inputs, whatsoever. The second variable which we have right here is our remote event, and this one is located inside of the replicated storage, so game get service, replicated storage, and then wait for child air combat. Now right here, we refer to the user input service, and then dot input begin just is an event which obviously fires when an input has begun, alright? And this means that you have started to press on a key or on the gamepad button or on your mouse button, okay? So that's all of the cases, yeah, which are being noticed via this event. And once this event fires, we receive two variables. The first one is the input itself, so the input which was done, either a mouse button, key, gamepad button whatsoever, and the second one is called game processed event, as you guys can read up here. What this game processed event is that it tells you whether an input was done on purpose or not. So was an input, or what was this input done while interacting with in-game elements such as GUI, such as chat for example, or an inventory or a shop, or not, alright? So that's what GPE does. And if not GPE, then this input was not done while interacting with in-game elements. And then we just continue, alright? So why is that important? To know whether an input was on purpose or not, because only then we can really tell that the player really wanted to do that input, okay? That's the reason why this is important. Now right here we have another check, which checks whether the player has pressed a desired key, okay? So we have input.keycode and 2 equals enum keycode q, alright? So the desired key at this point is q, and if the key is q, then everything right here happens. What happens right here is that we obviously fire server this remote event with the argument attack, but we will get to this later. What we do down here is that we mess with the camera, so we create some kind of camera shaking, and let's take a look at how this works, okay? So we have a loop which loops 4 times, so it goes from 1 to 4, and each time it waits, and each time it also messes with the camera offset right here. So what happens right here? So we first of all refer to game players local player. So our player dot character, so our character dot humanoid, our humanoid dot camera offset. So this is a property which, as the name suggests, stands for the camera offset, okay? And messing with this creates this camera shake effect. So as you can see, dot camera offset equals, and now vector3.new, so we replace the existing camera offset with something which is inside of here, and this something new, so this content right here is randomized. So we have math random from -100 to 100, so we create a random number in between those two numbers, and then we divide this by 200, okay? And we do that for all of the different axes as well, so X, Y, and Z. And you need to imagine that this happens 4 times, and this basically, so this randomizing of this camera offset creates that camera shake. And after this loop is over, we revert the camera offset back to 0, 0, 0, okay? So this is just for camera shake effects, so that you guys know, and this one just reverts everything back to normal. Now let's take a look at this fire seller right here. And for those purposes, we want to switch over to the server script, okay? As you can see, we have also created a variable for the remote right here, so as we have done right here as well. And right here, we just check for an event called onServer event, which happens when you fire server a remote event, which obviously has happened right here. So when you fire server a remote event, and when this event right here fires, then we receive the player who has fire servered and the arguments which have been passed, okay? Since we only have one fire server in this whole system, I'm presenting you, and in this one fire server we only have one argument. I just have one argument right here as well, and I already know that this argument right here, it tells the server script what to do. Therefore I've called it what. Okay, so if what equals attack. So if the server script is supposed to mess with all of the attack stuff, then we would like to continue right here. So that's what this check right here is for. We could even leave out this check since we only have one fire server in this whole system. I could even leave this empty and then just know, yeah, once this remote event has been fire servered, that, you know, the server script is supposed to do all of that combat stuff. Okay, but yeah, you can do that if you want to, but it is not really necessary. So what happens down here now once this check is passed? So we create another variable which refers to our player's character, or at least to that player's character who has fire servered, okay? And right here we are creating a ray, okay? And this one is important because this ray, so if you guys don't know what a ray is, let me just quickly demonstrate this to you. So you can imagine a ray as something like this, okay? So some kind of small line maybe, which is obviously invisible, okay? And this line has a starting point and an ending point, and they're obviously defined right here. So when you raycast, this is your starting point, this is your ending point, but we will get to this later on. So you have a ray, and everything which crosses the ray, which touches the ray, intersects the ray, call it whatever you want to, but which just, you know, just messes with the ray, let's say, is being detected. And why is this now important? So when you have a combat system, and when we create a ray each time we punch, then we can tell by raycasting, so by setting the ray starting point to our character and then the ray's ending point to something in front of us, we can tell whether something in between, so in between our character and a little bit in front of us, is in between. And this could be a potential enemy, alright? So raycasting is used to detect enemies which are in front of us, at least in this context, okay? Now, let's get into this. So, how does this work? What we do up here is that we are creating an empty settings template, so that's at least how I call it. So raycast params.new is an empty template which, yeah, just carries raycast parameters, aka settings, alright? And settings because we fill this template with stuff like filter type and filter descended instances. So we fill the settings template by telling the template that the filter type of this ray is going to be a blacklist filter. Means everything which is blacklisted is not detected, although they have crossed the ray. Okay. Second thing, called filter descendant instances, are those instances which you blacklist. So one more important thing to this is that the instance you add inside of this table, not only the instance is going to be blacklisted, but also every descendant of it. So literally everything inside of it, okay? And that's why I love to add the character inside of here, because not only the character model itself is then blacklisted, which makes less sense because the model itself is not a physical instance, but all of the body ports, the mesh ports, I don't know, the accessories whatsoever. So everything which is a physical instance inside of the character is now blacklisted from being detected by this ray. And that's good because we do not want to detect ourselves running into the ray and then, dealing damage to us and targeting ourselves. So that makes no sense. And that's the reason why we have to blacklist our character from this ray. Down here we are creating this ray by referring to the workspace, then call on Raycast, and then we have to add 3 arguments, alright? And 2 of them already known to you. So the first one is a starting point, which is our character humanoid root port's position. The second one is the ending point. So our character humanoid root parts c-frame dot look vector multiplied by 10. So the direction we are looking at multiplied by 10. Alright? That's the ending point. The third argument are the settings. Yeah, pretty obvious. And now, right here, we have another check. If ray, so this basically just describes the case when something has crossed the ray, and ray instance, so ray.instance refers to the instance which has crossed the ray, touched the ray, intersected the ray, call it however you want to call it. But this is the instance which has messed with the ray. So ray instance.instance.parent is a model. This is important because we really want to have an enemy in front of us, and an enemy is obviously an entity with a character model. Okay, so this can be a player, but this can also be an NPC. But the most important thing is that when you have somebody like that in front of you, then you will obviously, or then let's say the target or your enemy will obviously cross the ray with its body parts, okay? And that's the most important thing to know. So you want to look out for body parts. And what kind of attribute do all body parts have in common? Of course, they are members of the model, so of the character model. So therefore, when you pretend that ray.instance symbolizes or stands for a character model's body part, then ray.instance.parent has to be a model, okay? So the body part's parent has to be a model. If it is not a model, then you can exclude the case that the thing in front of you is an enemy with a character model, because that's what we're obviously looking for. Okay, I hope that this was understandable. Apart from that, another attribute of an enemy, which is inside of a character model, or which is a character model, is also that this character model has a humanoid, alright? So ray instance.parent refers to the character model, and find first child looks for this humanoid, alright? So is this humanoid existent inside of that character model? That's literally the third argument right here. And if that's the case, then we want to continue, alright? So then we have found our new target. So target ray instance.parent, so the target's character model. Alright, right here. So in order to understand this, you have to understand the idea I wanted to do right here. So the idea is that we have an int value inside of the script. So for every attacker, let's say, and this int value is first of all, the name of that int value is composed of the player's name and the target's name. Okay, so that we are able to easily identify the owner of that int value. What this int value does is that it is responsible to keep track of that combo system. Okay, so every air combat system I've seen so far is somehow a combo system as well, and therefore it is important to keep track of the current combo progress, and in order to tell when it is time to punch the enemy up into the sky and then slam the enemy down, or to even decrease the progress of our performer, so of our attacker, because the attacker just took too much time to get the job done, so to punch the enemy into the sky, so that's the reason why we need this int value. What happens right here is that we are checking whether this int value exists or not. So if not, script find first child player.name, and then these two dots, they connect this string with this string, so player name, target name. As I've told you, the int value is composed of both names, and if this instance is not findable inside of that server script, then we want to create it. So f instance.new int value inside of the script, of course. And then the name right here, I've told you, f.value is 0 by default, okay? Now, right here, we have different checks for each progress state. The first state is, of course, 0. So when the value equals 0, okay? And this is literally what we are checking for right here. So if then the reference to that value equals 0, then punch 1. So as you can see, we have a bunch of animations right here. So punch 1, punch 2, punch 3, finisher, knockback, knockdown. Okay. So you have to recreate them because my animations will not work in your game, alright? So what happens right here is that, to be honest, the content of this and this is literally the same. I could even fuse both together, you know. Let me actually do that. Nah, I cannot really do that because of this guy down here. Yeah, but let me still explain, alright? So what we're doing right here, I'm sorry, is that we have set up a variable, and then we refer to our character humanoid's animator, alright? And this animator instance is inside of the humanoid, as its reference already suggests, but furthermore, it is also responsible to load animations, alright? So what we have right here is that we have call on and then load animation, so we make use of that load animation function, and the animation you want to load has to be put inside of here. And as you can see by the reference, we want to load this punch 1 animation, and we want to make it play. So this loader then, after this animation was loaded, receives the loaded animation track, and then by using this track, we can play it. And the same goes for this one. I have called this LDR2, so loader 2. But this time we want to load an animation for the target. Okay, that's important. And the animation we want to load is called knockback. So we want to load this knockback animation after we have loaded the punch animation for our player, you know, and we want to play this, of course. And then I also have prepared sound, which is obviously not my sound, all right? So any of those sounds I use are not made by me, so credits to the rightful owners right at this point. Yeah. So we have the sound script punch clone, so we clone the sound, we parent it, means we put it inside of our target's humanoid root point, and then we play the sound. And game debris add item, so the debris, so when you add an item into it, the item disappears, alright, so the item is then gone. And we add the sound after 2 seconds. That's what this line right here does. So after 2 seconds, this sound is gone, alright. It is then at the debris. Now right here, what we do is we deal damage to our target. So target, a humanoid, take damage. So this take damage function deals damage to the humanoid, and the amount of damage you want to deal is then defined in here. As you can see, we have put a math random inside of here, which goes from 5 to 15. So a random number in between 5 and 15 will be dealt as damage to our target. Alright, and right here we are increasing the combo value. So this is the reference for the combo value, and then we declare that the combo value's current value equals its current value plus 1. Okay, so we increase it by 1, and right here we have a coroutine. So coroutine.resume, and we resume a coroutine which we newly create right here. All right, and what coroutines do is that they run the code they have inside of them. So they run this code without pausing the script, this whole script right here. So the code literally runs in the background, just to really understand how it works. And this is important because we have a wait right here, and wait 1 would obviously delay the whole script's progress by 1 second. But putting this inside of a coroutine makes this run in the background, and the whole script is then not interrupted or paused. But this code is still run, alright, and that's the good thing about using these. Now, after 1 second, so 1 second is the amount of time which is required to get a combo of 3 punches in order to do this air combat move, okay? So after 1 second, it is over. So after 1 second, your progress is reverted, your combo progress, right? And it works yeah, it works by the following. So what exactly happens after 1 second is that we check if this combo value first of all still exists. That's important because, as you guys know, this code is responsible to delete the combo value after 1 second. So imagine you run through this and then through this, through this, and then you run through this, and this one reverts your combo value back to 0. Then the requirement right here, so the second one, is met. And when this is met, this is then being destroyed. Now, the requirement of this one is also met because the value is still below 2. And then it also tries to destroy it. Okay? But the value is already destroyed. Therefore, we have to implement a check which checks whether the value is still existent. Okay? Otherwise, you would try to work with values which do not even exist anymore, and that's the whole point. Okay? That's the reason why you have to check whether the value still exists. Okay, and a second argument, the second requirement right here, let me explain this, is that the value is greater than its current progress right here. So let me explain this. As you can see, the progress of this check is 0, okay? Wait, I have to, yeah, is 0. Now, imagine you come to this point and you didn't even bother punching one more punch, okay? Means you stay at 0, okay? Or at 1. Yeah, at 1. Now, if you still stay at 1, then this requirement is also true, because your value has to be not greater or has to equal 1. So that's what these two symbols right here suggest. Now, this would mean that you didn't you didn't throw out some more punches, and that's the point. So if you just stop working on your combos progress, then you will lose the progress, obviously, and that's important, okay? Because if you would throw out another punch, then your combo values would be at 1 because it was obviously at 0 previously. Then you would come to this check, and then your combo value would increase by 1 again. Then it would be 2, and then this check would fail. So this check right here, okay? Now, the second part works the same way as up here. The only difference is in here. The number right here is 2, okay? And it is at 2 because the combo value's progress right here is 2, because after it is 1, it is increased by 1 more, and then the progress right here is at 2. Now, you have to increase this once more to really get out of this check, and this happens when you punch for another time. And yeah, this does not really happen in here. Oh wait, does it? Where is it? Wait. All right, look. We destroy the combo value, and then this check right here kicks in. All right, that's so and how it works. Yeah, nevertheless, this still works. All right, so that's just to explain that. Now, if your combo progress is at 2, then you wanna do that air combat stuff, and this is right here. So let me explain this. What happens is that your target is unable to walk or to jump because we have set the jump power and the walk speed to 0. Your target also receives damage. Okay. Now we have those loaders once again, and they now play punch 3 and the knockback. And we have this punch out once again. We have this debris stuff. All right, so you guys know about that. Also, one more thing I wanted to mention is that we now play punch 2 right here. Okay, so do not forget that. So at the second check right here, punch 2. Up here we had punch 1. Do not forget about that. Okay, now we get to the interesting stuff. So on how this air combat really works. So how you levitate the enemy up into the air and then back down. Okay, so I have used body positions to do that. I don't know what other games use, but I used body positions. I think that they are already deprecated, so I think you have to use this align position instance, but I didn't really look into it, to be honest, but I really have to, because working with deprecated stuff is not that good. But let's just use body position for this time. So how body positions work is that they just move your body by force into a certain position. And what we do right here is that we create a body position inside of our target's humanoid root part. We apply the biggest force which you can possibly apply, so MERTO huge. Okay, so to really forcefully levitate the player up into the air, and then we assign the position, and that's important. So the position which is assigned, or which has to be assigned, has to obviously be in the air. Otherwise, this whole air combat concept would not make any sense. So the position then is going to be our target's current position, or C frame, multiplied with another C frame, which levitates the character up into the air by 15 studs, and also 10 studs back. Okay, and we so those are C frames, all right, and we convert this to a position, so to a vector 3, to make the script be able to work with it. And we also create a second body position, so we do not obviously want our enemy to be up in the air, but we obviously want to levitate our character, the performer of the attack, also up into the air to be able to knock the enemy down. Okay, so character humanoid root part, as you can see, we apply the max force, so math huge, and we set the position to our character humanoid root part C frame multiplied with yeah, some C frames right here, which move the character up by 15 studs as well as we have up here, but -8 in front. All right, and we convert those C frames in position as well. Now, right here we have a coroutine runs once again, so you guys know about coroutines now, at least I hope so. So we wait 0.5 seconds after all of this stuff has happened, and then we play another loader, and this time we play an animation called finisher. So this is just a finisher move. So we play this on our character, on our performer, and the second loader is then being played onto our target, and this time we want to play an animation called Knockdown, and this animation is an animation which which makes the player just lie down, let's say, okay? So literally, as the name suggests, the player is then being knocked down. So we play both of them. We play another sound at this point. So not the punch sound, but the explosion sound. But the playing of the sound follows the same concept, okay? Now right here, we also refer to the replicated storage and then to an instance called ring shockwave. We clone this one, and this ring shockwave is just a shockwave, as the name already tells you. It is anchored and can collide as faults. Its parent is the workspace, so it is being put inside of there after it has been cloned, and the C frame is our target C frame, our target humanoid root part C frame, multiplied with some angles. So I had to multiply it with some angles, otherwise the rotation of that ring shockwave would have been hella wrong, you know. That's the reason why I had to rotate it. Right here, we set up a tween. So I've already explained the tween service in many of my videos, but let me explain it once again. So for those of you who do not know what it is. So what the tween service does, or tweening, is that it creates a transition from an instance property's first status to its second status. So let me just give you a quick example. So imagine you have a part, okay, and the transparency of that part is an attribute, aka a property of it. Now, let's say that you have the part's current transparency status, which is at transparency equals 0, so the part is fully visible. But you want the status to be at 1, so transparency equals 1, so the second status. Now, you can approach this via two ways. You can directly set the transparency from 0 to 1, that would work, but you would have no transition, it would look awfully bad, okay? Therefore, you want to use the tween service, which creates the transition for you. So instead of going from 0 to 1 directly, you might go from 0 to 0.5, 0.05, 0.1, 0.15, and so on, alright? That's how it would work. Okay, so this tween service creates this transition, as I've told you. And we now want to create a transition for a ring shockwave, so X. Okay, and we have set up a bunch of settings right here. So tween info.new. So the wait time, for example, so the time in which this tween is over. The easing style, which is linear, the easing direction, which is out. So those two are things which you can look up under Roblox Dev Hub. So they are just, some settings of the tweet service. And right here we define the goal status we want to achieve for each property, because with tweeting you cannot only create a transition for one property but also for multiple properties at the same time. As you can see, we have one for the transparency and for the size. Now, as I've told you, the transparency one, so we guys already, we had that in the example earlier, but size, so we also want to increase the size by 3. So the size should equal its current size multiplied by 3, okay? And what you have to do is that you have to play this tween, and right here, once this tween is completed, so this is an event, t completed, we want to destroy this ring shockwave, okay? And we want to wait 0.1 seconds, and after that, we are doing this fire all clients, which I've already told you at the beginning, but we will get back to this later. And after that, we set the first body position, so the target body position, to a new position, so to the target humanoid root part C frame, multiplied with another C frame, which goes -40 down. So obviously something underneath the target. And -40, you could argue, alright, so up here, you have put the target up by by 15, and now you want to put the target down by 40. Okay, so obviously you have to put down the target by 15. Why do I pick 40 though? Let me explain this. So the problem is when you pick 15, or the main problem with body positions is that the force which is applied, or yeah, the force is decreasing once you come nearer to this goal position. All right, so the nearer you are to your goal position, the weaker the force is which is applied. And what I do right here is that I set the goal position that high to keep this force pretty strong. And what I do is that I delete this body position then midway of the process of coming to this position, so that you're able to understand it. So yeah, but I think it was pretty understandable. So after 0.25 seconds, I can tell that the player has probably not achieved this goal position by -40, because yeah, by the fact that we have a base plate right here. All right, so that's the first thing. Second thing is this short amount of time, and the player is probably not at -40, but probably at this ground. And then we just delete this body position, and we also delete our body position, so which has levitated the perform up into the air. And then we have another coroutine, and after 2 seconds we stop the second loader, because the second loader has a looped animation. That's the reason why. Down here we delete this target. This target value. This combat value. This combo value. I'm sorry. And down here we just make sure that the targets, the target right here is facing towards our performer. Okay, and this applies to every state of progress right here. So it does not matter if you're doing the first punch, the second punch, or the finisher punch. This applies to each punch. So if each punch, we set the C frame of our target's humanoid root part to a new C frame. So this new C frame is composed of the position where the target should be, which is of course its current position, and the position it should face to, which is our character humanoid root part's position. Okay, now let me get back to this fire all client. So we refer to this air combat remote, as you can see, and then we do this fire all clients, and inside of there we put a C frame. Okay, so C frame new. So the first C frame is our body position, but just in C frame. Then we multiply this with -15. So as I've already explained to you earlier by this example, we go up by 15 studs right here, and we go down by -15 right here. So we are literally at the ground. Okay, so this ground height level which we wanted to attain. And we now need this kind of position for the shockwave right here, because as I've already told you, this fire client is now going to be processed inside of Air Combat Visuals. As you can see, we have this remote variable right here, and remote on client event will react to this one. Okay, and as you can see, this one already requires an argument called pos. So pos stands for position. Although this is a C frame, but it is still an information about some position stuff. So it requires this. And what happens is that we have another variable called module, and this one requires this GPO shockwave module script, and then just creates that shockwave on that position. So if you want to know more about this shockwave module, then check out the video I have made on that. Alright, so just go to my channel and check it out. And yeah, so this is it, guys. I hope that you have enjoyed it. If so, leave a like, subscribe, share this video to all your friends, leave me feedback in the comment section, guys. Take care and see you in the next video.